We are actually dealing with multiple linear regression. When we will be going with multiple linear regression is if we think that one of the independent variable is actually not exactly no, there is no dependence between one independent variable and another independent variable, then I can take both independent variables for predicting my y value, which is dependent. For example, if I was going to predict whether tomorrow will be holiday or not, the factors that will be depending is tomorrow maybe a government holiday, or there can be any functions tomorrow. Like that, many parameters may be there. So, how many parameters I'm going to take in such a way that those parameters do not depend on each other. So that's why I go for multiple linear regression. The main thing what we are going to discuss here is the parameter estimation thing. We know that our linear regression will be y is equal to mx plus b, and here we write that as y is equal to beta x plus sigma. Sigma is nothing but the error term or an intercept term we mean. Now what we are going to do is we are going to model the same thing for multiple linear regression, where we will be having y is equal to beta 1 x1, beta 2 x2 plus beta 3 x3 dot 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 beta k xk plus a sigma variable. Here, it means that I have several weight values for different inputs, and for each input, I need to estimate what will be my beta value. So the parameter to be estimated in multiple linear regression is nothing but this beta values. These beta values I need to estimate. So what I do, I consider all the beta values as a single term called as capital B. Now what I have to do is I need to estimate the weight values for each of my independent variables, that is x, provided that my total error is minimized. So when this is actually be a convex function, where when I plot my x and y in the relation on one side and the error on other side, the error will be actually decreasing from one end, and after a particular point it will start increasing again. So this is actually a convex function. So surely I'll be finding a minimum function over here. That minimum function I need to identify, and at that minimum function, what are the parameter values for beta? I need to identify. Those parameter values I need to estimate. So what I do, I model the error value as y minus x beta. Why I do this is, you know that we model this as y is equal to, let me change the pen size. We model this as y is equal to x beta plus sigma. This is what we actually do. If it is a linear regression, there will be only one independent variable x. If it is more than one variable, it becomes multilinear, where I have x1, x2, and so on. So this sigma term, I can write it as sigma is equal to y minus x beta. So that's what I written here. It is actually sum of squares, so I make it y minus x beta the whole square, right? So we need to estimate this particular term and solve for the beta value. I need to solve for beta value, right? So why I'm writing this y minus x beta the whole square, we know that it is not a normal multiplication, it is a vector multiplication. So whenever I multiply a two-dimensional vector or a matrix, I need to multiply as row and column only. I need to multiply like row and column. So what I do, I take y minus x beta, the whole transform into y minus x beta, right? This is what we do, right? In the table form also, we wrote like upper triangle and lower triangle and said that both are symmetric. So these are actually symmetric. We will not say that if there is two matrix A and B, we say that A into B will not be equivalent to B into A. That's what we will be doing, right? If you multiply A into B matrix, that will not be equal to multiplying B into A. Why? Because A and B are not symmetric. But this is not the case here. You y minus x beta the whole transform into y minus x beta is also same as y minus x beta into y minus x beta the whole transform. Anyway, you can actually do that. So that's what the case here. So I take that. Now I actually do the multiplication over here. Y minus x beta the whole transform into y minus x beta, which I get it as this transform I denote as dash. So y dash into y dash y minus I have x beta the whole transform into y on one side and y into x beta on other side. Since x dash beta dash is equivalent to x beta, that is symmetric, I make both of them as same and write it as minus 2ab. Minus 2ab is nothing but minus 2 x dash b dash into y plus and I need to multiply this x beta and this x beta. So I write it as x dash beta dash x beta. Right, this is what I write here. Now I need to solve for this in such a way that the total error is going to be minimized. So we know that if I want to find the minimization function with respect to a particular variable, then what I have to do, I need to take differentiation over that variable and make it equivalent to 0. So I make it, I take partial differentiation with respect to beta. I take partial differentiation with respect to beta. So dou of s of beta divided by dou beta is equal to, here there is no beta term. Here if you see there is no beta term. So the differentiation will give me 0 minus 2x dash beta dash y. So I'm having minus 2x dash beta dash y. When I derivate with respect to beta, I'll get only minus 2x dash y. If it is beta dash or beta, I consider as same. Why? Because I keep in mind that both transform and normal are symmetric. So answer will be minus 2x dash y plus this term x dash beta dash into x beta. Now how I do this is I have a note here, that is, if I have some vector in a space that m cross n, m cross one dimension, then I can, if I take the partial derivation of that particular variable, say dou z dash a z divided by dou z. Now consider this a value, right? Consider this beta, and this a is nothing but x dash x. Consider this a as x dash x. So if a term is like this, we have a formula like, if dou z dash a z divided by dou z can be written as a plus a dash into z. So we know that what is z? Z is nothing but beta. So I write beta here directly. Then what is a? A is nothing but x dash x plus, I want to take a transform also. I want to take that also. So I can write a, again x dash x. So what I get? I get 2az. I'm adding a plus a dash y because a dash and a are symmetric, so both can be considered as same itself. So I get as 2 into, what is my a value? X dash x. I take that x dash x into beta. That's what we actually write here. This particular term this we have written here, x dash x, right? Then I want to find the minimum value over here. So this thing I'm actually making it equivalent to 0. The first derivation will be equivalent to the 0. So minus 2x dash y plus 2x dash x beta is equal to 0. And I actually make everything, I remove this 2 constants, 2 will be removed, so that I get x dash x beta minus x dash y. This is what we have done so far, right? So this is actually most important when you actually want to do in pen and paper with respect to the parameter estimation for linear regression or multilinear regression using the principle of least square method. This is actually most important formula, right? Shall I actually proceed? This is what we actually discussed in the previous class itself, right? Right. Now we need to proceed it. Now how to get the beta value here? If I want to take the beta value out and bring all other values on the other side, I need to find what is the beta, right? That's what I need to find. What will be the value here? For beta is going to be, I can write it like x dash x beta. I just to go with an additional step, that is x dash x beta is equal to x dash y, and I say beta, it is going to be x dash y into x dash x inverse. So I write it like, it should be coming in the denominator, but I can also write it as inverse, x dash x inverse. X dash x inverse x dash y. So this is actually, I say it as the estimated b value. I put it as b cap. Why? Because I name it my parameter estimation for any linear regression or multilinear regression. You have beta 1 or beta 2, anything. You take the corresponding x value and find it, and this will be the estimated b value at the minimest range. Right? In the minimest range, I mean where the minimum error can appear. So this is what I, but I need to prove that this is actually the minimum beta cap value. If this is going to exist, then what I have to do is I need to take the second partial differentiation of this and then prove that that is actually a positive integer, right? So I'll put here, this is actually the derivative value here, and I take this again and take derive it one more time. This is, let it this be one partial partial derivation of 1 with respect to beta. With respect to beta, I have to do one more time. That is second partial derivation. Already it is actually dou SB by dou B, right? So I can write it like dou squared SB, dou squared S of B divided by dou beta. So what will be the answer if I derive it one more time? So I actually this term is actually available here, x dash x beta minus x dash y. So I want to derivate with respect to beta. So if I want to derivate with respect to beta, this term is actually considered as constant because no beta term is there. So this term completely will vanish. So the only term that will exist is actually this particular term, that is x dash x, x dash x. And we say that this particular term x dash x, when I multiply these two terms, even though if x value is negative, multiplying both negative numbers will give me positive, and if both x values are positive also, I'll give it a positive result. And since x dash and x are symmetric, this is actually equivalent to x squared. So I assure that the second partial derivation of the particular estimated equation is giving me a positive result. So I can say that this is always positive. This is always positive. So I am assure that I found a beta value in which the summation, the sigma term is actually minimized, right? So this is actually my beta value. So this estimate is actually done by using the least square method for multiple linear regression. The same can be used for linear regression also. It depends on the number of parameters. If I want to estimate beta 1 cap, then I take the corresponding x values and do it, right? So this is what the estimated b cap value with respect to least square estimation, right? I'll be asking you one question, right? For some sort of questions. So I'll be writing the questions. You just answer me whether it is you are able to answer or not, right? The inference is like what type of questions can be obtained from derivations like this if it is an MCQ kind of, right? That's what I'm going to ask you, right? Question number one is very simple. The estimated parameters for parameters for the given independent and dependent variables for multiple linear regression, right? The estimated parameters for the given independent and multiple linear regression for the which whether it follows dash property, what properties actually follows, and what are those parameters. That's what we're going to say, right? The estimated parameters for given independent and dependent variables for multiple linear regression is following.
Weights and bias.
Yes, it is going to be weights and bias. And what is the property? Symmetric property for the weight. And instead of saying it's bias, I'm saying it as an error term for weight and error. Right? Right? The estimated parameters is nothing but two parameters are going to be estimated. One is weight and other is error. and they are going to follow a property called a symmetric property. This is actually most important. Why? Because in our derivation, in several steps, because of this property only, we are able to proceed to the next step. If I want to say you, I had something like x dash into x when I want to expand y minus x beta the whole squared. I had a term x dash x and x dash beta dash and x beta, like that I had a term. I just added both, considering both are equal. I was able to say that they are equal. Why? Because this symmetric property hold, right? So this is first term. Second one, yes, let me take it. Yes, a true or false kind of, right? If I have two or more independent variables, the number of independent variables for a given x vector is equivalent to or equal to dash. This kind of questions can be there. I can actually find using some mathematical thing for a matrix. What is that? I said you're right. If it is equal to some k, then it means that there are k independent variables. I'll write the next question also. You try to find the answer for two. Right. So what will be the answer of this? The number of independent variables for a given x vector is equal to x may be having x1, x2, x3, like that. It will be having many x values. And if I want to find the number of independent x values, then what I should find? Anyone say, or shall
Scatter
I say?
plot, sir.
Scatter plot. Okay, scatter plot in the sense you are actually I am going to find everything separately. And another mathematical thing is, shall I find the rank of that matrix? I can find the two-dimensional vector matrix. I can take the rank of the matrix and do. And as you said, it can also be the scatter plot, and that I post in the third question. If in the scatter plot, if two x
They are
values are having
dependent
a pattern,
variables.
they are dependent variables. If they are having the same characteristic, then there will be a pattern in them, and I can consider they are dependent variables. Yes. Now coming to the equation kind of small equation kind of questions can be, what kind of methods can be used for parameter estimation for a multiple linear regression? For multiple linear regression, what type of methods are available? One is now we have seen, that is least square estimate, and other is,
Maximum recurrence.
Differentiation, sir.
yes, maximum likelihood estimate. First is least square uh, estimate. Just a minute. I'll take an eraser and rub this. Least square estimate. Second is maximum likelihood estimate. That's what you're going to see now. Maximum likelihood estimate. And when we ask, when I say you the maximum likelihood estimate, you will be having two ways of estimating the beta values. So we need to be identifying the first way. What will be the formula for the least square estimate? Using least square estimate, the weight value for input x can be represented as what? What will be the weight value? for the input x. Weight is nothing but it is beta. What will be the beta value for the input x? The equation we have just seen now, right? That is final equation. That's what you have to write here. What is that? X dash x inverse this is x dash x inverse into x dash y. This is actually the estimate for the beta value where I'll be having my sigma value at the minimum. My sigma is nothing but error, and I'll be having my error at the minimum position, right? And that's all. There is no I can some intuitive questions like how the pattern will look for a multiple linear regression. And remember that matrix value. I draw a matrix like that and say that what is this particular portion, everything, right? I draw a matrix like this, and I just separated and showed if this is y and this is first if this is and this is y and this is x1 and this is x2. What is this particular portion? And these diagonals are nothing but the same values, and this is the scatter plot between y and x1, and this is a scatter plot between y and x2, and this is the scatter plot between x1 and x2. And this scatter plot, it is actually the thing what I have represented here in the third one. They should not have any linear pattern, or not only linear pattern, they should not have any pattern. The x1 and x2 should not have any pattern. So then only I can say that x1 and x2 are independent, right? And these should have a pattern. Y and x1 should have a pattern. Y and x2 and should have a pattern. If they have the pattern only, then I can say that okay, I can actually estimate y from x1. I can actually estimate y from x2. If these should have pattern, these should not have pattern. These can have pattern and these should not have pattern, right? So these things you can actually see. I also share the notes for linear regression. Hope you have taken the screenshots also for the least square estimate, right? I'll go for the maximum likelihood estimate. Okay, now I'll erase this. Now the second way of estimating the parameter in multiple linear regression or any regression term is nothing but maximum likelihood estimate. First, we will see what is maximum likelihood. If I want to find what is maximum likelihood, first I need to understand what is likelihood. It will be seeing that first. Right? I'm having some an example of maximum likelihood function. Right? Let us see this maximum likelihood function from the probability basis. Right? Assume that I'm having a box. I'm having a box, and in this box, I'm having three red balls. Three red balls are there, and two black balls are there, and four green balls are what that color is there. Four green balls are some colors is there, right? Now I need to pick a random ball from this, and what is that probability for this particular ball? Say I say that this is actually going to be some input x, and what is that probability for the input x to be red, black, green? Can anyone say? I'm having a box full of balls, and for if I take any random ball from that box, I should see what is the color of that particular ball. So what will be the estimate from this? What is the total number of balls? 3 plus 2, 5, 5 plus 4, 9. Of this 9 balls, 3 balls are being red. So what is the probability of getting the red ball out of these 9 balls is nothing but 3 divided by 9. So similarly for black, what I'll get something like 2 divided by 9, and for green I'll be getting something like 4 divided by 9. So this is what a probability distribution function. I say that as a probability distribution, and I say it is discrete. Why? Because I have the terms with bins. So I say it is discrete probability. and I going to relate this particular term with ML. Now I go for an machine learning kind of thing. Now I have my system. This assume that this is my system. My system is going to recognize a group full of images. Many images are there. The images are nothing but there are images like animals and birds in the particular page. Right? There are many animals and birds. Now my machine learning algorithm should go into this particular problem space and recognize what are the items are animals and what are the items are bird images. I need to identify. So this is what I need to do. Again, I have something like an x value. I have something like an x value, and I need to estimate whether it is animal or bird. But there is a small difference between I do it in a discrete probability distribution and in machine learning I have a small difference. I'll explain what is the difference that will occur when I do it here. If I do here, I have a concrete information here that how many balls are there. I have a number. I have a number. So the total sample space is available. I need to estimate only one thing. What is the probability of x? This is what I need to identify. Probability of x in some distribution. I say that distribution as theta. In some distribution theta, that is probability of x comma theta. And I have many probability distributions like Poisson distribution, Bernoulli's distribution, binomial distribution. Many distributions are available to find the x value given a theta. This theta is nothing but the model, the probability distribution function. Same here, now what will happen is now I can represent this as a number itself because the whole sample size is available to me. But in machine learning, the same thing is available. A model has been put inside. The model have to recognize how many animals are there, how many birds are there. The model knows what are those are animals, what are those are birds. The model is having some information, some knowledge on how to identify the animals and birds. But we don't know in how much probability it identifies animal and how much probability it identifies bird. I cannot track these numbers. These numbers are actually a question mark in machine learning. These numbers I cannot say initially itself. I directly have something that is probability of some x given theta. I directly have like this. I don't have this initial information. So why what I go for a person called as Bayes. Now the Bayes person come here and he is giving an information on how to find this particular value. So what Bayes is saying that if you are not having any proper full data for doing a particular operation, then what you can do is you can directly take the input data and estimate the data which is actually required. So you know that when you go for estimating using Bayes theorem, you are actually going to estimate something called as conditional probability. If this is actually then what will be the probability of this to exist? Probability of, for example, x given some data. That's what I'm going to do. So here also the same thing going to come. What happens is I'm having I need to identify a probability of some variable x given some data. I don't have this data initially. In if it is normal distribution like a discrete term, I can actually count this data and say. But here I don't have that. I don't know what will be the data. I don't know what data will come here. I'm having some x, and I need to determine this x given data. Right? Probability of x given some data. Now, according to Bayes theorem, so it is going to be p of data given x into p of x divided by p of data. Right? There is some information to understand here. This is actually the conditional probability formula given by the Bayes theorem. Right? Now, I'll explain what are the things that is actually required for us and how it is related to the maximum likelihood estimate. Here I'm having p of x given some data. So what is that? If you give me the history of data, I could predict what will be the output variable. That is what how many times a particular instance may occur. That's what the p of x of data will say. This P of X is nothing but the probability of the particular X term. How many number of animals are there, how many number of birds are there, what is their probability to occur without any dependence. And this is the probability of data, how many such data are available in history. So these are actually my independent things with probability, but this is actually dependent. This is something different. What is this? Probability of data given X. This X can be either animal or X can be either bird. So what I say, you if X is equal to animal, then what does it mean? You give me all data which on analysis says that X is always animal. If X is bird, then what that is says, you give me data in which on analysis always give the answer as bird. So what is nothing but the P of data given X is, I'll give some answer. You give me the records or question in such a way that the answer is what is given. I directly give the answer. My answer is X. For getting this answer, you give me the data. So this kind of information is actually called as likelihood function. This function is actually called as likelihood function. Why? Because whatever data I actually require or actually like, that data alone I will be taking. For example, if my X value is actually going to be my animal, then I should take data pertaining to animal alone. If I take X with respect to bird, I take data with respect to bird alone. So this function P of data given X is actually called as the likelihood function, which is what we are interested to analyze. Right? The same thing I can actually relate to the multiple linear regression. What is available there is, there I need to estimate something called as beta value. I need to estimate a beta value. That beta value should be estimated with respect to my error value sigma. I need to estimate beta given sigma. Sigma, how sigma should be there? Sigma should be as minimum as possible so that I can get a better beta parameter value. So this is what I need to estimate. Generally, how I can say is I need to estimate P of some the data given X, or I need to estimate P of theta given X. I need to estimate P of theta given X. If it is X or X bar theta, I need to estimate it like P of theta given X. This is what we are going to do. So what are the challenges that will occur when I do this P of theta given X is, condition number one is, if the history is not available properly, then I cannot estimate this likelihood function clearly. Why? Because I say that if I want to answer like X is equal to animal or X is equal to bird, I need the data with respect to that. If the data is not available, then I cannot go with the finding the likelihood function. This is the main reason why we say that regression will not work good when you don't have enough historical information. We say another thing for decision tree learning, right? For decision tree learning, we say when you don't have enough data, or if you have missing values or NA values, you can go for decision tree learning. But we don't say that for regression. Why? Because if you go for a regression based algorithm, you should have a thorough knowledge on the historical information. If the historical data or the internal data is not available fully, then your estimate will be wrong, right? Why? Because I'm going to estimate my beta value. If I was not properly estimating that beta value, then my entire result will go wrong. I'm going to estimate beta in such a way that error will be minimized. If my data itself is having some error or like missing values or NA values, then everything goes wrong, right? So this is what the difference when I go for the regression terms. This dependency is not available when I go for the least square estimate. Why? Because in least square directly I run everything and take everything from the term sigma. Directly I take from the sigma only. Now there is no direct representation on data in least square estimate. So what is in least square estimate? In least square estimate, you can run the program. Once error comes, you learn from the program. That's what in least square estimate. In maximum likelihood, you can go along with the data. Directly you take the data, you analyze the data, and by analyzing itself, you can find whether a multiple linear regression can be applied on the particular data or not. Directly you can estimate when you use maximum likelihood estimate, right? Now, in the next class, what we will be doing is we'll be deriving same like the least square estimate and find what will be the formula for beta when I go for maximum likelihood estimate. The same beta value will be found with the condition that the error sigma will be minimized, right?